Good morning, guys, and welcome to probability. This is our very first lesson, and it's pretty basic, so I just want to give you the notes here to get us started in the unit, okay? First of all, probability has to be between 0 and 1. A probability of 0 is absolute 0, and a probability of 1 is absolute certain. Both those are very hard to come by. The example I like to use is when people jump out of an airplane to go parachuting and their chute doesn't open, and their emergency chute fails as well. They're jumping out at something like 5,000 feet, and you would think the probability would be 0 of living, but people have lived. Okay, so it's not 0. I wouldn't count on the fact that you'd make it, and I'm not sure I'd want to live if I did make it. But the point is, to get 0 or 1, they're absolute. It's very, very important in a lot of real situations and very hard to come by. Okay. All right, theoretical probability, this is called classical is another word for it. It's what you already know. The probability, if I roll a die, a single dice, a die on the floor, okay, to get a 1, well, there's one way for it to happen out of 6 total. So the probability of getting a 1 would be 1 out of 6, which you already know intuitively. So the probability is the number of ways for an event to occur divided by the number of total number of possible outcomes. All right? Okay, empirical probability or experimental probability. Okay, if I roll the die on the floor 10 times, and let's say I get 2 6s, that would be the frequency of my event would be 2. It happened twice out of 10 trials. Then I would assume at that point that 2 out of 10 would be the likelihood of getting or 1 out of 5, if I reduce that, would be the likelihood of getting a 1 on a die when I roll it, okay? Now, that would be inaccurate, okay, but truthfully, this is really the best way almost. So if I have a coin, it should be approximately 50% chance of getting heads and tails. Now, if I flip it, 5 times, I can't even get an even amount. See how that works? And then if I flip it 10 times, I think it would be pretty unusual to get 5 heads and 5 tails, even though that's what we expect. But over the long run, if I do it a lot of times, I should get about 50% of each. Okay? Now here's the little special part to this. If I flip that coin 100,000 times, okay, and I end up getting heads 60% of the time, then even though the coin's supposed to be 50%, I can see that it's not on that coin. Okay, so if I do it many, many, many times, okay, then the empirical probability or experimental is going to reveal the true probability. Okay, there was a gentleman, I still remember this from college, and I think it's Carl McGraw, something like that. Anyways, he used to go to Vegas, and he was a math guy, and all he did really was record. He would sit at the roulette wheel, and he would just record what it landed on, record forever, long time. And he finally figured out that they weren't actually fair, that certain casinos would be more likely to say land on red or a certain number. And then once he had that information, he would go back and play. And then the longer you run an experiment, like the longer he played, those accurate results would come through. So if you know in Vegas that the odds are always in the house's favor, but they were now in his favor, and he won a ton of money. And then he would get kicked out of each casino, and then he would come back later with disguises on, and they'd catch him and throw him out. But he won a ton of money, and he was really just conducting experimental probability and finding out the true probability of each of the little ball when they roll it landing on certain things. Okay? All right, subjective probability. This really isn't, they call it personal. This is an expert's best guess. Best example of that I have is like right now, it's football season. So the odds of someone winning, if you go to Vegas, you can bet on that. But there's so many factors that go into that. And they may use math formulas to calculate that out, but it isn't really statistically based. There's too many things that are unknown. Okay, so that is not a good one. And like I said, betting is the best thing. You go to the racetrack down towards San Diego there, and Rancho Santa Fe, and they have odds on the horses winning, but if they had a bad day that day, there's all kinds of things that interfere with that, and those aren't scientific like odds. Those are really with feelings and emotions, and someone might be really good at figuring that out, okay, an expert, of course, okay, but That is not really good statistics. Those are the three types. Okay, an event, when we talk about things, an event is any collection of results or outcomes of an experiment. So when I said the probability of getting a 1 when I rolled that die on the floor, the event was a 1, okay? When I talked about the guy jumping out of the parachute, the event was living, okay? All right, a simple event, that would be like my rolling a die on the floor, okay? An event consisting of just one outcome, okay, instead of a combination of things occurring, like getting a 1 on a die and then getting something else on a deck of cards or something like that, more complicated. So a simple event, just one outcome, one event's happening, did you get it or not? Complement of an event, this is very important here. Okay, so it's not the event, not A. If my event A, I'm going to call it A, it's just a name, that doesn't mean anything. But my event is getting that 1 on that die, all right? Then the probability of not getting a 1, since a 1 is 1 out of 6, would be the rest would not be 1, they'd be 5 out of 6, okay? So we denote that A complement with a little c there. The probability of A complement is 1 minus the probability of event A happening. So 1 minus 1 out of 6 would be 5 out of 6. That would be the complement of getting a 1, okay? All right, and the sample space is a list of all the possible outcomes. On my simple die example, it's not how many, that's what students tell me a lot. It's not 6. Okay, when I roll that die on the floor, it's not how many, but it is what can you get. It would be, it's an actual list, okay, so it's a list. It would be 1, 2, 3, 4, 5, 6. It'd be a list of all the outcomes you could have. Okay, that's what the sample space is. All right, 2 last things for our little, this is going to be part 1. Okay, law of large numbers. As the number of independent trials increases, the long run relative frequency, that's the probability of the event happening there, how many out of the total of repeated events gets closer and closer to a true value or a single value, all right? Okay, and this is what I'm talking about. If I toss that coin 100,000 times, the more I do it, the odds are going to get closer and closer, not the odds I should say, but the relative frequency, the number of times I got out of the total, okay, that is going to get closer and closer to the true probability. If my coin's fair and it's 50%, then the more I do it, it'll end up coming closer and closer to 50% over time. All right, and if it's not, it'll converge on that number. If it was 60%, that coin's a weighted coin or something, then it's going to show that it's 60% over time. It's going to reach that. Okay? If I only flip it 1 time, that's not accurate. If I flip it 5 times, that's not accurate. But the more times I do it, okay, then it'll show the true probability. All right? I hate to even mention this because some people think of it now, but the law of averages, that's when you say, well, you know, if I got 5 heads in a row, I'm due for a tails. Okay, that's the idea here. So let's see, if I have 7 heads in a row, you're due for tails. Okay, this is false. The events are independent. Every time I flip that coin, it has no memory of the last time I flipped it. So the last, whatever, 7 times have no influence on the next time, okay? Now, if my coin's not fair, that might be more likely to get heads, okay, if that's true. But on a fair coin, it's not unlikely to get some number like 7 heads in a row when I'm doing a lot of flips, okay? So an independent event means that previous events have no influence on the next outcome, all right? Okay, and this is the study of coins, all right? And this is about the law of averages showing it's false. There were 200, they tossed a coin 100,000 times, okay? And then there were 2,987 streaks of 5 heads. So you had 5 heads and you say you're due for tails, okay? The next toss though, there were 1,550 heads and 1,431 tails. There obviously weren't more tails, okay? So that equals there's no law of averages. All right, guys, that's it for part 1 of our video.